Okay, let's continue on the last subtopic in your chapter 5. Chapter 5, part B, two-way ANOVA. If just now we have one-way ANOVA, so for this time around you will have two-way ANOVA. So why is it called two-way ANOVA? Because it's involved two factors, factor A and factor B. If factor B, if one way is only one factor, if two-way it's involved two factors. So this one is the model for two-way ANOVA. You will have this one. And then the flow chart for two-way ANOVA, you have to remember this one. When we start the process, we will check or we will test, is there any interaction effect between factor A and factor B? If there is interaction effect, yes, you have to stop the process. If no interaction effect between factor A and factor B, you have to test the effect of factor A and you have to test the effect of factor B. So don't worry much, we will look at from the example later on. Okay, so what we want to test in two-way ANOVA is we want to test the interaction. If you notice here, we have three hypotheses. First, we must check the interaction. Is there any interaction effect between factor A and factor B? If there is an interaction, stop the process. If there is no interaction, you have to test for effect factor A and effect of factor B. Okay. The same goes to your one-way ANOVA. You also have the F-test. F-test here, we can calculate from what we call it here, ANOVA table. So we look at ANOVA table later on here. Okay, the ANOVA table. This one is source of variation, sum of square, degree of freedom, mean square, and the F-test. So actually we want this F-test. How to get F-test here? F-test and F-test. So look at one by one. So normally the sum of square will be given. How do you get this one? Okay, we'll look at later on one by one. What is R? What is A? What is B? And how do you get MSA? SSA divided by A minus 1. MSB. SSB divided by B minus 1. MSAB, so SSAV divided by degree of freedom, and MSE, SSE divided by the degree of freedom. And how do you get the F-test? We have three F-tests here. This one F-test for factor A, this one F-test for factor B, this one is F-test for the interaction. So this is the formula. So we'll look at the example. So don't worry much, you will understand when you do the example. Alright, two-way ANOVA. Two-way ANOVA, what is the purpose of two-way ANOVA? We want to test, is there any interaction effect between two factors? Between two factors. So in two-way ANOVA, you will have factors A and factor B. Okay, two-way ANOVA. Two-way ANOVA means that you will have two factors, factor A and factor B. These two factors came from the independent variable, and you will only have one dependent variable. And capital A, we call it as factor A, where the small a, we call it as number of factor A. Capital B, we call it as factor B, where small b, we call it as number of factor B. Next, we will have small r. Small r, we call it as replications. Replication is how many experiment, how many times or experiment you do for each treatment. Okay, and then you will have K. K is treatment. How do we determine treatments in two-way ANOVA? K is equals to A times B. Number of factor A times number of factor B. Right? So these are the definition. So look at example. For example, two-way ANOVA. I want to test, is there any interaction effect of teaching method of different teaching method and different section to the final exam results. Okay, so I have one teaching method and I have section. So this will be my independent variable, where factor A is teaching method, factor B is the different section, and I have the exam results will be my dependent variable. So adakah menggunakan different teaching method dan section yang berbeza memberi results yang berbeza? For example, like this, I have online learning, face-to-face learning, and exercise learning. Okay, so this is my factor A, teaching method, and I have section 1, section 2, and section 3. Okay, student section 1 using online learning, the results is 100. Student section 1 online learning, second student 50, 60. So there are 3 students. Student section 2 using online learning, first student 95. Student section 2 using online learning, second student is 80, and so on. So I will have this data of final exam result. So here is the teaching method, will be my factor A. Here is different section, will be my factor B. Here is the final exam result, will be my dependent variable. This factor A and factor B will be my independent variable. How do we get the treatment? K. K is A times B. A is number of factor A. I have 1, 2, 3. 3 times number of factor B. I have 1, 2, 3 equals to 9. So what is the 9 treatment? Online learning section 1. You got first treatment. Online learning section 2, second treatment. Online learning section 3, third treatment. Okay, face-to-face section 1, face-to-face section 2, face-to-face section 3. You got 6. Exercise section 1, exercise section 2, exercise section 3. So these are your treatment. Okay, R, replication. Replication is for each treatment, how many experiments they do. For example, online learning section 1. How many data we have? 1, 2, 3. So 3. R is equals to 3. Okay, so don't worry much. We will look at the example.